Hello everyone. Today we shall discuss about relations and functions, second chapter of NCERT class 11. Okay, so let me start. So before we dive into the concept of relations, we shall look at what is something called as Cartesian product of sets. So let me write it. Cartesian product of sets. Okay, so suppose you have two sets. So let me take it as A and B. There are two sets, A and B. So now how do you find the Cartesian product of these two sets? Okay, so we write the Cartesian product of set A and B like this, A into B. So but this is read as A cross B. So how do you find? So this also produce one set. So I write it like this. So you see here, A is a set, B is a set, as we know, and A cross B will also produce a set. And what will be the objects or elements of this set, this cross product? That will be ordered pairs. So what is ordered pair? Ordered pairs are just two elements that we write within a pair of parentheses. So I write it AB. So these two elements you can see A and B, and I have written it with the within a pair of parentheses. So this is nothing but an ordered pair. Now what is this element A and what is this element B? So we write it something like this. A, the first element, will be a member of the first set. So we write it like this. A is a member of set A, and the second element of the ordered pair will be a member of the second set. That means B is a member of the second set. We write like this. Fine. So I just want to say something more about what is ordered pair. Ordered pair. Okay, ordered pair we write within a pair of parentheses. So suppose this is A comma B. So here two things are important. One is pair. You can see pair means two elements together. So you can see A, one element, two elements, that we have written within a pair of parentheses. So this is a pair. And order. Order means here the sequence in which these two elements appear. So for example, here you can see B appears after A. So it has maintained the sequence. So this is an ordered pair. There may be another ordered pair which may have something like BA. So you can see now A has appeared after B. So this is also an ordered pair. But these two ordered pairs, though their elements are same, but they are not same ordered pair because of the alteration of the sequence in which these two elements appear. So these two, they are different ordered pairs that you have to remember. These two are different ordered pairs because the elements in which the same the order in which the same elements appear is just reversed, or they are not same. Okay, fine. Now this is fine. Now we shall again come into this one. So if you look at this one, what is now A? A is nothing but an element of set A. Okay, and what is B? B is an element of set B. Okay, okay, fine. So you can write, instead of n, you can write here each also. So that means an element of set A will make an ordered pair with an element of set B. You can read it like this, or else you can also read it like this. Each element of, that is more precise. So if I write here each. So that means each element of set A will make an ordered pair with each element of set B. So that is how you get the Cartesian product or cross product of two sets. So let me work out an example. Let me show you with the help of an example. So suppose you have a set here A. So suppose A is equals to X and Y, suppose, and there is another set which is nothing but 1, 2, 3. Suppose you have these two sets. Now what will be A cross B? What is A cross B? So that is nothing but this set will have some ordered pairs. So how you construct these ordered pairs? That means the first element, so you see each element of set A will make a pair with each element of set B. So let me do it step by step. So first element of set A, so that means X, with the first element of set B, which is 1. Then first element of set A with the second element of set B, which is 2. Then first element of set A with third element of set B. Okay, then X is complete. X cannot make any more pair. Then Y. So Y will make Y, or the second element of set A will make a pair with the first element of set B. So I write it like Y comma 1. Then Y will make a pair with second element of set B. So Y comma 2. Then Y comma 3. So it goes on like this. Now you can see how many ordered pairs are there in this cross product. So you have 1, 2, 3, 4, 5, 6. So you have total 6 ordered pairs in the cross product of these two sets. Okay, now we shall look into some, we shall solve one more example, I guess. So if I have, say, if I suppose I have something like this set A, which is nothing but, you can say it as coat, shirt and pant. So C for coat, S for shirt and P for pant. And suppose one more set which will have two colors, suppose R for red and G for green, suppose. So now what will be the cross product of these two sets? So let me find it out. A cross B is equals to first element of set A, C, first element of B, which is CR, then CG, then SR, then SG, then P R P G. Okay, so you have total 6 elements, 1, 2, 3, 4, 5, 6. So in that means all the possible combinations will be given by this A cross B. So for example, here it is coat of red color, then coat of green color, then shirt with red color, shirt of green color, pant with pant of red color, pant of green color. So it is like this. Fine. Okay, so now we shall look at some important observations about this Cartesian product of two sets, Cartesian product of the sets A and B, or Cartesian product of three sets. It does not really matter. So first of all, first thing is some important observation. So let me write it like this: important observations. important observations. Okay, so first observation is two ordered pairs are equal if and only if the corresponding first elements of the two ordered pairs, first elements are equal and the corresponding second elements are also equal. Corresponding second elements are also equal. Fine. Suppose you have two ordered pairs x, y, and another ordered pair is a, b. So these two ordered pairs are equal only if a is equals to x and b is equals to y. Okay, these two ordered pairs are equal only if the corresponding first elements, that means a is equals to x, and the corresponding second elements, that means b is equals to y. So this is all it says. Then the second observations. Second observations is how many elements will be there in the cross product. So that means if suppose there are some elements, say p elements in A. So this is the cardinal number of set A, which is p, and suppose cardinal number of set B is equals to q. Okay, so now what will be n A cross B? What will be this? This will be NA multiplied by NA multiplied by NB, which is nothing but P multiplied by Q, PQ. So NA cross B, or the cardinal number of this cross product AB, will be PQ. So that means how many ordered pairs this cross product will have? This will have PQ number of ordered pairs. Okay, so now the third observation is, suppose third observation is, you can say that third observation is okay, if either or both, either A or set A or set B are infinite, then infinite. If either set A or set B is infinite, then so is A cross B. A cross B. So what does it mean? It simply means that if any one of these two sets are infinite, then A cross B will also be an infinite set. Okay, then the last one, The fourth observation is, suppose you have like 3 sets A, B, C, A, B, C. So if you find the cross product of these 3 sets, so A, B, C. So there are 3 sets A, B, C. If you find the cross product of these 3 sets, that means A cross B cross C, then it will, how you will find the result? It will be A, B, C, and here such that A will be a member of set A, then B, the second element, will be a member of set B, then C will be a member of set C, like this. Okay, so I think this C, this is small c, this is small c, this is capital C, this is capital C. So let me write it like this. I'll use it as D. So I'll use it like D. I'll use it like D, and this one will be D. Now this is fine. Okay, and this is called as ordered triplet. Ordered triplet. Ordered triplet. This is called as ordered triplet, A, B, D. You can see the first element will be a member of the first set, the second element will be a member of the second set, and the third element will be a member of the third set. So this is what it is. Now one important question that you need to understand. So suppose so you know that there is something called as set of all real numbers, which is written with R like this. Okay, R like this. So now suppose you have 2-dimensional axis like this one, X, this is Y, this is Y dash, this is X dash, and this is the origin O. Okay, and you roll this real axis R, set of all real numbers, on this X axis such that 0 falls on this point origin, and the plus R, positive side of R, goes in the positive direction of X axis, and the negative R, this one, negative R falls on, roll on the negative side of X axis. Okay, and similarly R will, the positive R you will fit vertically also, such that positive R rolls in this direction and negative R rolls on this direction, and the 0 or origin, it falls on this point. Okay, now so this is the condition that is given. Now what will be R cross R? What will be R cross R? Remember, this R is nothing but set of all real numbers. So what is R of R cross R? So this will produce actually a to infinite 2-dimensional area, 2-dimensional surface area, and it will be infinite. Okay, because R, you can see on both sides it goes infinite. Okay, or you can say that what will be its dimension? It will be 2-dimensional, and its unit, if it is in meter, say it is in meter, so it will be in meter square. Please understand this one. Okay, so now one more, like if you have, say, same as before, now you add one more dimension, that means I'll take into account the Z axis also. So suppose you roll again the real axis, that means plus R on this direction, plus r, and negative r in this direction, and similarly negative r in this direction, similarly negative r in this direction. So then what will be r cross r cross r? What will be r cross r cross r? This will be three-dimensional volume, and this will be infinite actually. Infinite, its volume will be infinite. So that means the whole universe comes in r cross r cross r, if you fit it like this. Okay, and its unit, what it will be? It is three-dimensional. Its unit will be, if it is in meter, then it will be meter cube. Okay, so now the next point. Now we shall dive into something called as relation. What is relation? Now we shall dive into something called as relation. Now, suppose, what is relation in real world situation, in our day-to-day life? What is relation? So there can be, some relations I am writing. So suppose this is father-son relation, or mother-son relation, or maybe father-daughter, or mother-daughter, then brother-brother, brother-sister, sister-sister. So you can see, basically I have written so many relations. In each relation there are two entities involved. For example, in this one, there is the one entity is father, the other entity is son. In this one entity is mother, the other one is son. So it goes on like this. There are two entities involved in each relation. Similarly, when we talk about relations in mathematics, there also two entities are involved. So which two entities I am talking about? So we shall now look into it. So just remember, whenever we talk about the relations in this chapter, so we actually define, or we try to find the recognizable link or recognizable connection between the two entities of the ordered pair. For example, if the two elements of the ordered pair is A and B, so then by relations we actually try to find the relation between these two entities, these two elements. So here this is nothing but relations, or relation between relation, or you can say that recognizable link. Recognizable link or connection, or recognizable link or connection between A and B, the two ordered pairs that we have seen so far. Okay, so now second thing is that, please understand this one. So whenever we shall write this relation, whenever we write relation is, in this context, it is written as R. It is written as R. So what is a relation? So relation is some kind of set. Relation is nothing but some kind of set. So now from where we get relation? So relation is derived from the cross product or Cartesian product of sets. So here I write it as cross product or Cartesian product of sets. So from Cartesian product we get a relation. Okay, so this is cross product. As you know, this is a set actually. Cross product is also a set, and relation is also a set. And from relations we finally get something which is called as function. Okay, so this is also a set. Also we shall look into it what is this, but this is the sequence. So relation is special type of cross product, or if you derive with some criteria, you put on cross product and you get relation, and then again you filter out some relation and you get function. So necessarily relation is a set and function is also set, and this one is also set. This you have to remember. Now relation, this one is set, I have told you, but I told you that relation, how do we write? A comma B. So that means it is a recognizable link or connection between these two entities or these two variables. Now important thing is that how can we express the recognizable link between these two entities or these two elements? How can we write this relation? Now you see there is a subtle difference. Now you actually say it is xy, say it is xy, say it is xy. Okay, so how I can write relation between x and y? So first way, one way is to write with the help of a statement. For example, if I write x is greater than y. So this is through a statement I have written. Okay, so I can write it like this: x is greater than y. So this is the way we express relation. So one is statement, or this with the help of these inequalities we can write it like this also. Okay, or I can also write it like this. Suppose I write x plus y is equals to 1. So what does this indicate? This equation actually indicate the relation between x and y. Or if I write, suppose x square plus y square is equals to 2. So this equation also, it indicates the relation between x and y. Okay, this is the way we write the relation. Okay, but these will be a set. See, we shall look into it what is that actually. So suppose now, so this we write with the help of this thing, this either with a statement or maybe a mathematical equation or mathematical inequalities. Okay, so we shall look into it. Okay, say you have, suppose, just let me think like this. So suppose you have two sets, A, which is say AB, okay, say P, say I, okay. Say this set you have this set A. Okay, say you have one more set which is B. So B, suppose you have say Amit, say you have what you have Arun, say you have what okay, Preeti, you have like Ileana, suppose. Okay, you have these two sets. So now if you want to find the cross product of these two sets, then how can you write? So I write the cross product of these two sets. So it will be A with Amit, A with Amit, then A with Arun, then A with Preeti, then A with Ileana, then P with Amit, then P with Arun, then P with Preeti, then P with Ileana, then I with Amit, with Arun, then I with Preeti, then I with Ileana. Okay, so this is the cross product we have. Okay, so you can see there are three elements, 1, 2, 3, and here there are 1, 2, 3, 4. So what will be, how many elements will be there in A cross B? It will be 3 multiplied by 4. So it will be 12. So let me check it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are in total 12 elements, 12 ordered pairs in A cross B. Please understand. Now I told you that relation will be derived from this one. Relation will be derived from this one. I also told you that relation is a set. So now how do we write actually relation? So relation, first of all I write relation. So I write relation, this will be a set, and in that set there will be ordered pairs. So let me take it as X and Y. Okay, now I write, I told you how do we express relation. We write it in terms of say equation or statement or inequalities. So here I shall use something called as statement. I shall use statement. So I state as like X is the first letter in or of Y. X is the first letter of Y. And what is X? X is a member of this set A, this set A, and Y is a member of set B. Y is a member of this set. So this relation I have written. So if I write it completely, okay, in roster form, then how can I write it? So now if I follow this protocol or this statement, then I can write R or relation. See, this R is relation and this is a set, and this is the statement. Here we shall write either statement or some inequalities expression, or maybe an equation, mathematical equation or algebraic expression. Okay, so here R. So R is what? X is the first letter of Y. So let me check this one. So this one. So you see, A is the first letter of Amit. So I'll write A, Amit. So this is taken. Then A is the first letter of Arun. So A, Arun. Then I shall check only this condition or this statement. A is not the first letter of Preeti. First letter of Preeti is P. So this is rejected. This is also rejected because I is the first letter of Ileana. So this one is also rejected. A is the first letter of Amit. Okay. So this one again rejected. This one is selected because P is the first letter of Preeti. So I'll write P and Preeti. Then P. Ileana rejected, I. Amit rejected, I. Arun rejected, I. Preeti rejected, then I. Ileana. So this is accepted because I is the first letter of Ileana. So you can see, so I. Ileana. I write like this. Now I told you this R is basically derived from this A. Please understand this one. So you see this R, how many ordered pairs it has? It has 1, 2, 3, 4. It has 4 ordered pairs. Okay. So also remember that this R which is a set, is basically a subset of this cross product. So R is a subset of A cross B. So this you have to remember. R is a subset of this cross product. So now the next question that appears, next question that we shall solve is, how many relations can we derive from the Cartesian product? Okay, so now the next question is, how many relations are, which is a set. This is a set, this relation is a set. So how many relations can be derived? Can be derived from Cartesian product. Product of A cross B or A and B. Okay, so how many? So the solution is just, okay, now we shall solve this. How shall we solve this? Solution. So suppose n of A, cardinal number of A is P, and suppose cardinal number of B is Q. Okay, then what will be n A cross B? This will be PQ. This is PQ. Suppose this number is M. So let me take it as M. To PQ is, I mean, it's for simplicity I have taken it as M, one single letter. Okay. So now this is, I'm sure this is clear to you. Now, if so, this one is set basically. This is a set that you have to remember. Now, any set that has M elements. So out of these M elements, how many subsets could be constructed? How many subsets? How many subsets could be derived from M objects? How many? So that you already know, you have read it in the first chapter. So the number is 2 raised to M. So that means from M elements, or 2 raised to PQ, you can also write it as 2 raised to PQ. That is same. So that means from M elements you can construct 2 raised to M subsets. Okay. So earlier I told you that R, the relation, this relation R is basically a subset of the Cartesian product. That means A cross B. A cross B. So that means what? That means you can derive this. R is nothing but subset of this A cross B. So how many subsets you can construct from A cross B? So you can construct 2 raised to m or 2 raised to pq. So that means how many relations are possible now? How many relations are possible? So that means how many relations? So there are 2 raised to m relations. 2 raised to m number of relations could be relations, or this R, you can say that this R, which is nothing but a set, this one, which is nothing but a set. Okay, so 2 raised to m relations could be derived, from A cross B, which has m elements. So this you have to remember. This is very important. Fine. Okay. So now we shall look at one more example. So suppose you have in the context of relation, we shall look into, like, in the context of relations, what we shall look? We shall look into some terms, some important terms. So first one is image. What is image? Image. Second, we shall look into what is domain. Third, we shall look into what is range. Then fourth, we shall look into something called as codomain. Okay, so we shall now look into what is image. So suppose you have a set, say it is A. So A, suppose it is 1, 2, 3, 4, 5, 6. Okay, so this is given in your book. Okay, so suppose you have one more set B, which is again same 1, 2, 3, 4, 5, 6. Okay, so now this is given. So then how many elements will be there in A cross B? So there will be total 6 multiplied by 6, which is 36 elements you will get. 1 with 1, 1 with 2, 1 with 3, all the way till 1 with 6. Then 2 with 1, 2 with 2, all the way till 2 with 6. Then this way you go till 6, 1, 6, 2 till 6, 6. So totally you will have 36 ordered pairs in A cross B. So I think this is clear. Now if I write one relation, suppose I write some relation which is xy, such that y is equals to x plus 1. Y is equals to x plus 1. And what is x? X is a member of this set A. And y is a member of set B. So this is given. You have to write the relations, all the possible relations. How do you write it? So you see, x and y, the relation between x and y, this we have written in terms of an equation. Okay, and this is the whole relation, which is nothing but a set. Okay, so now if I prepare I'll prepare one table. So this one is x, this one is y. So this is 1, 2, 3, 4, 5, 6. Okay, so if this is 1, then what will be y? Y is 1 plus 1, that means it will be 2, 3, 4, 5, 6, this will be 7. Okay, so now I shall take help of something called as arrow diagram. So let me do it. So suppose this is, and this is B. Suppose this is A and this is B. So here I shall take X, here I shall take Y. So this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. Similarly 1, 2, 3, 4, 5, 6. Now you see, this pair you have to take, this ordered pair, 1 with 2, X is 1, Y is 2. So if you take X is 1, then Y from B, because Y is a member of B. So 1 is mapped to, 1 is mapped to 2. You can see here 1 and 2. Then the second ordered pair is 2, 3. So 2 from X is mapped to 3 of Y. So this is 2, 2, 3. So all the way it goes like this, 2, 3, then 3, 4, 4, 5, 5, 6. So 3, 4, 4, 5, 5, 6. Now you can see the last one, that means 6, 7. So from 6 it is mapped to 7. So from 6 it is mapped to 7. But is there any 7 here in B? There is no 7. So that means this is rejected. This we shall not take into consideration. Okay. So here you have, so I have taken all the maps, mapping from set A to set B. Now you see this image is always used in the context of, this is singular, that means one single point. See, 1 is having mapped to 1 point. So this is, so that means image of 1 from set A, image of 1 is from set A is 2 in set B. So image of 1 is 2, image of 2 is 3. You can see this is one single point. So that is why it is, so it may be more than 1. It may be more than 1. Okay, it may be more than 1 also. But generally, most of the cases it is singular, 1 point. It may be more than 1, that we shall look into. Or in case of relation, it may be mapped to more than 1 point, so more than 1 image, no problem. Okay, so then, so this is, that means you have understood, I guess. So image is, that means image of point 1 is 2, image of point 2 is 3, image of point 3 is 4, image of point 4 is 5 in set B, image of point 5 is 0.6 at set B. Okay, now what is domain? So domain is a set that you have to remember. So this is a set. So which set I am talking about? Which set? Domain is a set. Domain is nothing but the set of all first element of the relation. So what is the relation? If I want to write this relation, so what will be the relation? So relation I can write it from here. So this is first 1, 2. So 1, 2. Then it is 2, 3. 2, 3. Then it is 3, 4. 3, 4. Then it is 4, 5. 4, 5. Then it is 5, 6. So till this point. So 7 is not there, so that is why you shall not write it. So this is the relation. Now you can see in this relation how many ordered pairs are there? 1, 2, 3, 4, 5. Okay, and in A cross B there are 36 elements. But relation works like a filter. So after filtering out we get only 6 ordered pairs in the relation. Okay, now this is the relation. Now what is this domain? This domain is a set Okay, this domain is a set, so I shall write it here, domain. Domain is what? Domain is the set of all first elements in this relation. So set of all first elements, this one, this X, set of all first elements. So this will be 1 2 3 4 5, set of all first elements. So 1 2 3 4 5. So this is a domain, this is the domain of this relation. Okay, now what is range? Range is also a set, please understand. Now what is range? Range is nothing but set of all second elements of the relation. So set, that means 2 3 4 5 6. So this is range, 2 3 4 5 6. So this is the range. Now what is codomain? Codomain is the whole set B. This whole set B is the codomain. Okay, so what is codomain? So I write it, codomain. Codomain will be same as B, this set. So this is 1 2 3 4 5 6. So this is all about your relations. Fine. So I'm sure you have understood this one. Fine. So again, the main point is that R is a subset of this A cross B. So you can check it here. This R is basically a subset of A cross B. Okay, because you will get this 5 ordered pairs which is a subset of A cross B. Okay, fine. So now we shall move further. Now we shall look into what is called as function. Now we shall look into something called as function. What is function? I told you function is a special type of relation, or you can say it is a subset of relation. So I can say that relation a relation F is said to be a function if and only if each element, okay, said to be a function from, said to be a function okay, you can say a relation F from a non-empty set A to, okay, just a minute, I'll write it. F from a non-empty set A to a non-empty set B is said to be a function if and only if each element of set A has one and only one only one image in set B. So one and only one means what? One and only one means this is also, you can call it as unique. Unique, one and only one image in set B. So I repeat, a relation F from a non-empty set A to a non-empty set B is said to be a function if and only if each element of set A has one and only one image in set B. Okay, now we shall look into it, how actually it is. Okay, so earlier I have shown you one relation, that is earlier what I have shown you is, say A cross A is equals to A is equals to 1, 2, 3, 4, 5, 6. Okay, and what is B? B is 1, 2, 3, 4, 5, 6. So this I have shown you. So now what will be A cross B? A cross B will be total, it will have how many? 36 elements. Okay, so the relations that I have shown you earlier in the last example, so it was something like this: xy such that y is equals to x plus 1, where x is a member of set A and y is a member of set B. This I have shown you. So with the help of this one, you have got I have drawn, one arrow diagram also. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I have, the arrow diagram was like this. Okay, arrow diagram was like this. This is set A, this is set B. X will be taken from here, Y will be taken from here. So now, according to the definition of the set, so I have told you a relation F from a non-empty set A to a non-empty set B is said to be a function if and only if each element of set A has one and only one image in set B. So each element, so you can see here 1, 2, 3, 4, 5. The sixth point, it does not have any image in set B. So this relation is not a function, because this 6 does not have any image in set B. Okay, so now suppose I derive one other relation maybe. So this relation I derive something like this. This is x, y. And I call it as x is such that x is equals to y, and where x is a member of set A and y is a member of set B. So let me check whether this relation is a function or not. So if I draw it, so then what? X is equals to y. So you can see, if I draw it, this one, this is A, this is B. Y will be taken from here, x will be taken from here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So x is equals to y. So that means this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So x is equals to y. So that means 1 will be mapped to 1. 2 will be mapped to 2. 3 will be mapped to 3. 4 will be mapped to 4, 5 will be mapped to 5, 6 will be mapped to 6. Now you see, each element of set A has one and only one image in set B. You see, this 1 has only one image, this 2 has only one image, this 3 has only one image, this 4 has only one. So if I want to write this relation, then how I can write? This relation can be written as 1 1 1 1, then 2 2, then 3 3, then 4 4, then 5 5, then 6 6. So this is now, it is a function. This is a function. Okay, because it satisfies all the condition to be a function. So this relation is a function, but this relation is not a function. This you have to understand. Okay, you see. So this is just a subset of A cross B. This R is also a subset of A cross B. So one subset is a function, another subset is not a function. That, okay, fine. So now I'll solve one more. Like suppose, what is something called as a real valued function? What is something called as a real function? What is something called as real valued function? Okay, so I write it here. Real valued function, and there is something called as a real function. There is something called as real function. Now what is this? So in these, you know, there is something called as domain. There is something called as range. Okay, in this real function also you will have a domain, then a range. Now in case of real valued function, this range will always be set of all real numbers, or R. Set of all real numbers, or subset of R. R's subset. Okay, and domain can be a R or its subset, or it may be complex number. Complex number in case of a real valued function. Okay, and in case of a real function, this range will be R or subset of R. That means R's subset. That means set of all real numbers, set of all real numbers. So either R or subset of R. And the domain will also be R, set of all real numbers, or subset of R. Okay, this is the thing. So only here, in case of real valued function, this domain can be complex numbers. That's all. Complex numbers or its subset, whatever it is. Okay, so in the next video, I shall look into some functions. Okay, so thank you.